The year is 1956 and the famous Swedish company FACIT have just brought out their new model CA1-13 multifunctional semi-automatic electro-mechanical calculator. This calculator, as well as performing addition and subtraction, also features automatic division and automatic shifting when multiplying. Also, this model is equipped with a mechanism which brings the calculator to a halt as soon as the accumulator registers all zeros or nines, and its sliding quotient coupling dispenses with the need to fill out the dividend with zeros. The attractively designed and fully functional layout of this machine is carefully chosen to aid you in your everyday numerical calculations. Furthermore, it is so easy to use that you will be doing fast, accurate work after only an hour or so of practice. This calculator features a very compact keyboard layout with only 10 numerical keys, which can be operated using only one hand whilst tabulating your results with the other. After a short time, you'll soon learn how to calculate speedily and accurately and discover that you're not even looking at the keys, just like in touch typing. Its compact design means that it takes up far less room on the desk than other much more bulky and heavier calculators which are currently on the market. And its innovative roller feet makes it easy to move about on the desktop. You just lift up the front of the calculator and you can push it backwards and forwards with ease. Below the Dalton type numeric 10-key keypad are the 3 register clearing keys. To the left are the 2 multiplier control keys, the negative key, the right carriage shift key, and the main and secondary control levers. To the right are the add, subtract and divide keys, the left carriage shift key, the tabulator key, and the combined subtraction and division stop key. Above the keyboard are the 3 output registers. Register number 1 is the 13-digit accumulator register, which holds the answer when adding, subtracting and multiplying, as well as the remainder during division. The 8-digit counter register number 2 shows the quotient in division, the number of items summed during addition and the multiplier in multiplication operations. Register 3 of 9-digit capacity immediately shows each figure as it is entered from the numeric keypad. These indicators above each register can be slid along to mark off the position of the decimal points, and the red internal arrows show in which column the machine is now operating. A red marker here tells when register 2 is decrementing. Before demonstrating the multitudinous features of this very compact machine, I'll remove the one-piece die-cast cover and let you take a look inside. Just look at all the many gears, levers, springs, pivots and pinions squeezed layer upon layer into this compact machine. The manual drafting methods available to the engineers of old was restricted to pencil, paper, compass and ruler, set squares and drawing boards. So how anyone could have designed these machines without the modern computer-aided design systems that we use today is a real credit to the engineers of the 1950s. I once read somewhere that prospective engineers who wanted to work on the design of these very complicated machines were first given a test to see if they could visualize in 3D. They were asked to picture a 3-inch painted wooden cube being cut into 1-inch cubes. They were then asked how many cuts were made and how many of the 1-inch cubes had 0, 1, 2, 3, 4, 5 and 6 faces that were painted and how many were left plain. If they passed the test, then they got the job, and the calculator manufacturer was assured that he would be employing one who could cope with the complexities that you see here. I've replaced the original 2-pin connector with a modern 3-pin earth plug and rewired the earth bonding. I also replaced the old leaky spark suppression capacitor assembly with 4 modern metal foil polypropylene capacitors in the same circuit configuration. I also adjusted the centrifugal speed governor on the universal Electrolux motor in order to slow its rotation speed, thereby easing the stress on these 60-year-old mechanical systems. Let's perform a calculation so that we can see these mechanisms in action. Without the soundproof damping afforded by the cover, this will be a little noisy. Okay, let's have some fun and carry out some basic calculations to see how this wonder of mechanical engineering performs. Prior to each calculation, we have to ensure that the main control lever is in the correct position and that the registers are cleared. Let's add some numbers. 487, 394, and 85. There's a sum in the accumulator, and register 2 holds the number of items which have been added. Now for subtraction. Let's clear what we had before. We can enter the minuend of 1283 into register 3. Then the subtrahend of, for example, 768 is subtracted by pressing both the substop and the divide keys together. 768. There's the difference in the accumulator. In case you need a count of the number of items subtracted, you place the main control lever into its center position, press the negative key, clear the registers, then enter the minuend, for example 800. Then the counter register 2 will keep a tally of the quantity of items subtracted, like so. Another 10. And another 10. Counter register 2 keeps a tally of the quantity of items subtracted, in this case 3. For the above operations with numbers larger than the 9-digit capacity of register 3, we add as many digits to the accumulator as can be held in register 3, then shift left for each additional digit to be entered, then add the remainder of the first number. Then you set up the second number in the same way and complete the operation. For example, first set the main control lever, clear the registers, enter a large minuend of 987654321321 by entering 987654321321. Then we'll enter the large subtrahend of 87654321010 by 876543210 and a pen 10. Then we press the sub-stop and the divide together for subtraction as before. Bloody button's fallen off. And there's a difference in the accumulator register 1. Now for multiplication. Let's multiply 9876543221 multiplied by 54321. Register 1, the accumulator, has the product, register 2 holds the multiplicand, and register 3 contains the multiplier. To square a number, we simply enter it onto the keyboard, 9876, and press the equal sign. And there's the square of 9876 in register 1. For dividing, the main control lever has to be moved fully to the right. Let's enter a dividend of 126358. Fully to the left. Then we'll divide this by 40221. Again, fully to the left, and press divide. And there's pi, the quotient, in the counter register 2. For the calculation of a reciprocal, for example 7, you can carry out the division as the reciprocal of 7 is in register 2. If we clear that first, or you can simply press the negative key, enter 7, and add with this key. In this second case, the result in the counter register 2 is greater than the correct answer by 1. So you need to subtract 1 from the least significant digit. Now let's try multiplying three numbers by a constant factor of, for example, 879. So first we move the main control lever fully to the left and clear the registers. Enter the constant of 879, then we'll first multiply it by 46. And there's the first product in register 1. Now we'll multiply the previously entered constant by 132. there's the second product. Next we'll multiply the constant by 9. And there's the third product. How about subtraction to a negative result? First we set the main control lever to its centre position and clear the registers. Let's subtract 68 from 57. This row of 9s signifies a negative result which will turn into a meaningful answer by entering a few 9s before the last numbers in the accumulator. And the numbers in the accumulator are 89, and we now perform 2 divide presses. And disregarding the row of 9s here, the answer is minus 11. Finally, square roots. We'll use the divide and average method to find the square root of 484 using a first guess of 20. First we set the main control lever fully to the right to carry out dividing and clear the registers. Now we enter 484 and divide it by 20. This gives us 24.2 in the counter register. We add this to the first guess and take the average. .2 added to 20 and divided by 2 gives us the new guess of 22.1 in counter register 2. 484 now needs to be divided by this new guess. .484 divided by 22.1 gives us a little more than 21.9. We add this to the previous guess and again take the average. Adding the two previous guesses of 22.1 and 21.9 gives us 44. We now take the average by dividing by 2. We can now see that the results are quickly converging to 22, which is the square root of 484. Let's move the control lever to the left and square 22 just to confirm this. 22 squared equals 484. The secondary control lever only comes into play when the main control lever is in the central position. And when the secondary control lever is in the left position, the carriage does not shift. When it's in the right position, it shifts to the right. So let's demonstrate that first with the secondary control lever in the left position. We'll put 8 in register 3 and move it along. Then we'll perform a few additions. You can see that the carriage is not shifting. Now we'll move the secondary control lever to the right and perform the same additions. And you can see that the carriage is shifting to the right. So there's the FACIT electro-mechanical calculator. Thank you for watching.